Welcome to the Connect with BMC Helix ITSM and Remedy webinar series. During today's webinar, you're able to ask questions of our panelists. The Q&A and the webinar recording will be posted a week from today's broadcast to our YouTube channel. Today's topic is Discovery Patterns, TPL for Beginners, and Lisa Keeler will take us through this content. Over to you, Lisa.
Thanks, Greg. Hi, I'm Lisa Keeler. I'm a lead technical support analyst, and I've been working with the Discovery product for over 10 years. Today we will discuss using run pattern to test patterns, and we will discuss the TPL syntax, and finally, I will suggest some best practices. BMC Discovery discovers network assets and the software running on them across your enterprise, as well as the relationships between those assets. Custom discovery patterns can be used to enhance the discovered data. In the previous webinar in December, we learned about the discovery data model. We learned how to read the key components of a discovery pattern, and we learned about query traversals. The December webinar link can be found in the communities. Today's webinar will provide more in-depth coverage of the pattern language known as TPL. Why would you want to customize discovery? Some examples are you want to add location information or add ownership or organization information. You want to add data in a required format. If you want to create a new report based on the current data, then you can just write a query. But if you can't create the report because the data you need isn't discovered, then you may be able to write a discovery pattern to add the data you need. If you know other programming languages such as C, Java, or Python, then you will easily learn to use TPL. So for those of you who might not be familiar with programming languages, I suggest that you could take a free Python course, such as Learning Python 2 at Codecademy. Discovery was originally mostly written in Python 2, and more recently the code was converted to use Python 3. But learning Python 3 may not be free, whereas learning Python 2 is free at many training sites, including Codecademy. And the basic concepts of programming languages are mostly universal. To be really clear, TPL is not Python, but conceptually there are similarities. 3 similarities between Python and TPL come to my mind. They are both procedural languages. The data types and the use of data types are similar, and the string manipulation functions are similar. And now I'm going to show a demo. I wrote a pattern that I called Hello World, and right now I'm looking at my pattern in Notepad. You can see I'm using TPL version 1.13. The module is Hello World module, and I have one pattern in the module called Hello World Pattern version 1.0. Okay, and then between these triple quotes is my comments about the pattern. And then it continues on. I have a tag which is required, and my only tag is, I just called it custom. The trigger is on a host. If a host is discovered, it's existing or it's created, then this pattern will be triggered. Now, when the host is discovered, then this is an assignment statement, and this variable called host node, which is a variable I made up, that is going to point to the host node that we're discovering. So what does the pattern do? Well, here's the body between the keyword body and end body. Mostly it has some log statements. Okay, so I'm logging that I'm in the pattern, and I say what the host name is. Between these percent signs, I'm getting the name from the host node and putting it into the log statement. So it'll say Lisa1 entered my custom pattern, hello world, host equal host A. Then I'm logging actually hello world in different languages. So in Spanish, English, French, Portuguese, and Vulcan. And I'm showing the different levels of logging. So the log.debug, that's only going to be logged if reasoning is running at debug level. The default level for reasoning to run and for any service to run is info. So most likely all these other 4 log messages will appear in the log, because if it's at info level, you'll get all the rest of these. You'll get the information logs, the warnings, the errors, and the critical errors will all be logged. If debug mode is turned on, you'll get all 5 of these messages. Then I am using this syntax here. I'm adding an attribute, a new attribute called told the world hello, and I'm adding it to the host node. So host node dot told the world hello, and then an assignment statement colon equal yes, and it's a string yes. Then I am calling the model dot add display attribute to say I'm adding this told the world hello attribute to the host node. And then finally, I have one more log statement, and I'm saying basically hello world completed. And I'm telling you again, the name of the host, and then also the value of the new attribute called told the world hello, and the value will be yes. So between the percent signs, we're getting the value and putting it in to the string that's being logged. So then we have the end of the body and the end of the pattern. So this is minimal pattern. There's not a lot of bells and whistles. It's small. So next we're going to see, how would I run this pattern in Discovery? How can I test it to make sure it does what I want it to do? So here I am in my Discovery system, and I'm going to go to the Manage Knowledge page, and I would like to upload the pattern that I just showed you. So I'm going to click on Upload and choose the file and click Upload. So I'm going to show you now how to test this pattern without actually running a discovery, because one way to test it would be to run the discovery, but we're not going to do that right now. So I'm going to choose some hosts. I'm just going to click on my 307 hosts here and pick a couple of, let's just say the top 2 hosts. I'm going to put them in what's called a manual group. So I selected each one that I want in the group, and I'm going to click Actions, Manual Groups. Now I don't have any yet, so it just asked me to fill in the name of the group, and I'm going to call it Host Group and click Create. So then the check mark means that these hosts are going to be in the host group, and that was done by default. So I'm just going to close this. Okay, now that I have a group of hosts to test the pattern with, I'm going to go back to the pattern page here on the first tab where my pattern module is showing, and I'm going to click on the one pattern that's contained in the module. Now that I'm showing the pattern, I click Actions, Run Pattern. And there's only one manual group on my system, so that group is chosen for me. We're running this pattern against that group of nodes that I put into the host group. It's a group of 2 hosts. I can choose what level of logging I would like. By default, it chooses debug. And my pattern is very simple, so I don't need to get any extra data. So I can click Run Pattern now. Okay, the run pattern finished, and this shows me that 2 nodes were submitted from the manual group. That's because it contains 2 nodes. And all of the 2 nodes met the trigger conditions. If I clicked on this all, it would show me the 2 nodes that met the conditions. Now, here is the log that was the result of running my pattern. You can see that this is the first host from the Lisa 1 down to Lisa 2. That's the first host. And then this is the second host. So anyway, it's triggered on the first host where it says host is agent ID, etc. These are the 5 different languages for Hello World. And then finally, I have my Lisa 2, Hello World completed. The host is the same, of course, as it was up here. And the new attribute called told the world hello equals yes. And then here's my second host, where host is AIS, etc. And then the same thing, the end of it, and then the told the world hello equals yes. Now, if I actually go back, after I've run the pattern, if I go back and look at one of these hosts by clicking on it, then I scroll down to look at the attributes. At the bottom of the list, I should find my new attribute under the other, and here it is, told the world hello, and the value is yes. Now, if we go back to the Explore data, then we look at the host list again, and we choose to customize the query. You're going to see something interesting. If I click on Show All under Attributes, and I scroll down to the T's, there's my new attribute, told the world hello. Now, I'm going to show you a different way of finding that. I could just type in here, told the world hello. And I clicked on that after it completed. So now I've added it to the query, and I can refresh the results. And now my report shows that for the top 2 hosts, the value is yes. The value for all of the other ones is not set. If I were to select all of the hosts and then put them in the manual group and then run my pattern again, then all of these hosts would have the value of yes. We learned in the demo how to use run pattern to test your pattern. The main reason to use it is to get the log output to see if it looks correct to you. And as you saw, also it will actually add and modify attribute values. But you need to understand that run pattern is very different from running the discovery itself. The trigger is different and simpler, for one thing. Let's say that I had a pattern that triggered on a software instance, but I only had host nodes in my manual group, then my software instance pattern is not going to trigger. I would have to directly add software instance nodes to my manual group for that software instance pattern to trigger. So the trigger is different. Also, when you use run pattern, it is not in the context of discovery. There is no credential. There is no connection to a target host. And therefore, if you have a more complicated pattern using things that we're going to learn about later, such as discovery run command, those commands are not actually executing on the target host because, again, there's no credential. It's not in the context of discovery.
Variables are assigned a value using an assignment statement. The assignment operator is :equal. An equal sign by itself is a test for equality. So :equal is used for assigning a value to a variable. There is no announcement of the type in TPL, such as int I equal 1. Instead, the type is implied. Patterns should be consistent in the use of type. It's a runtime error to attempt to add an integer to a text string, for example. Here are some sample assignment statements which will create values with the different data types. The assignment statement stir1 : equal in double quotes ABC123 creates a variable called stir1, and the data type of that variable is a string. The reason it's a string is because a string enclosed in double quotes was assigned to the variable called stir1. Therefore, it's a string. Second example is star2 : in single quotes 1, 2, 3. So double quotes or single quotes can be used to create a string. Star3 : in double quotes Lisa's string, and there's a single quote inside of the string. This single quote is ignored because the string is enclosed in double quotes. Likewise, if you enclosed a string in single quotes, then any double quotes inside the string would be ignored. So the second data type we have here is integer, and here's an example of creating an integer. int1 : 456. This creates a variable called int1, which is, the variable is a name that I made up, and the value is what I assigned to that variable. This is a numeric value, mainly because it's not enclosed in double quotes or single quotes, but also because it's a series of numbers. And there is no floating point data type in TPL. If you need to use floating point data, there's workarounds for that and has been discussed on the community. The next data type is called time. Really, it's more like a date time because it has a date and a time component. Here's examples of setting the time. We have time1 : time.current. So that sets the variable called time1 to the current date and time. Our second example is time2 : time.parseLocal, and then we gave it a string of 2020-05-12. So this string could have also had a time in it, but we only put a date. So time2 actually will be a date of May 12th, 2020. There are other time functions that are documented in the documentation. The next data type is list, and here's some examples of creating lists. The first example creates an empty list and assigns it to the variable called list1. List2 is a list of 3 items. It's actually 3 strings, and it's a list because it's enclosed inside of the list delimiters, which are square brackets. List3 is using the function called list to create a list. So since it's a function call, then the arguments are enclosed in parentheses, like other function calls. And so it's list, open parentheses, and then the 3 strings with commas between them, and then close parentheses. And finally, we have the table operator. Here's an example of creating a table. We have table1 : the table function is used here, similar to the way the list function was used here. So then we call the table function with the correct arguments. Variable names or identifiers can contain letters, underscores, and numbers. They start with a letter or an underscore, and names or identifiers that start with 2 underscores are reserved for the system. So some valid variable names or identifiers would be my underscore variable underscore name, or without underscores, you could just have my variable name. Some examples of invalid variable names or identifiers would have spaces in them, such as my space variable space name, or dashes. Dashes are not allowed because dashes are interpreted as a minus sign. Also, special characters are not allowed inside of variable names, and a variable name cannot start with a number. Logging is important for writing custom patterns. If your pattern isn't doing what you expected it to do, then you can add more log statements and analyze the log output. Logging for discovery patterns will be found in the user tideway log twsvc patterns.log file. Or if you use run pattern to test your pattern, then the output is right there on the screen in the UI. You can use %signs within the log strings to put the values of variables into your log statements, such as this notation here where we have $host.name %. That's getting the name of the current host and putting it into the string that is logged. Logging is always on in discovery. The question is, what is the log level? The log levels are debug, info, warn, error, and critical. Debug provides the most logging, and critical will provide the least logging. And info mode is the default logging level. Debug messages will appear in the log only if logging is at the debug level. If logging is at info level, you will get info messages as well as warning, error, and critical messages. When the logging level is at debug, you'll get all of these kinds of messages: debug, info, warn, error, and critical. If your logging level is at warn, you'll get warning, error, and critical. If your logging level is at error, you'll get error and critical. And at critical, you'll only get critical log messages. Since debug logging is only shown at debug level, then to see the debug logs in discovery patterns, you either have to use the run pattern method that I showed you in the demo, or you would have to turn reasoning on to the debug logging level. Okay, now we're going to talk about if statements. The if statement structure is if condition then, and then there's an optional elif, and then there might be an else statement, and then there's a required end if at the bottom of the statement. So if condition then, and you could have an elif, and you could have an else, and then an end if. The expression operators inside the if statement are the equal sign for testing for equality, the less than sign, the greater than sign. Then less than, greater than sign together is equivalent to saying not, or you can use the word not. Then we have the less than or equal and the greater than or equal signs. On the right side is an example of using the if. First, I've defined two lists, the animal list and the book list. The animal list is cat, dog, bird, and the book list is the cat in the hat and one fish, two fish. So then here I'm using my if statement. If animal list and size animal list is greater than 0. So what this is doing is saying if the variable called animal list exists, if it exists and has a value really, and the size of the animal list is greater than 0, meaning that it actually has some entries in it, then I'm going to send a logging statement, log.debug, and I'm going to say animals, and then I'm going to print the value of the animal list. So it would print cat, dog, bird. And then else if, elif, there's a book list, and the size of book list is greater than or equal to 1, which is equivalent to saying that it's greater than 0. Then we're going to print out a debug statement in the logs with the value of the book list. Else, we're going to print out a debug statement in the logs that says there are no animals and no books, and then end if. So that's the end of my if statement. And you notice that everything is neatly indented. This is a good convention to follow. The TPL doesn't require nice indentation, but your patterns will certainly be much more readable if you use some good indentation. Stop statements are very useful. They help you avoid errors during the runtime of your pattern. And by using the stop statement, you can avoid a lot of unnecessary indentation and nested if statements. The stop statement does kind of what it sounds like. It stops further execution of all the statements in the pattern. So it ends the pattern effectively. So here's an example. If not host, meaning the variable host is not defined or has no value, or it has a none value, then we're going to log an informational statement saying no host found, stopping. And then we stop. And then there's the end of the if, end if. Now, if there is a host value, then all the rest of the statements in the pattern will be executed. And here's, we're setting a variable called host_name to be the value of host.name. So this host.name won't be executed if there's no host, and therefore we won't get an error, a runtime error, when we're running this pattern saying that this variable has no value. So without stop, you would have to check that the host has a value before calling host.name. And here's an example of that. If host, then hostname : host.name. So this basically caused my pattern to be indented further over, whereas if I had used the stop statement, then my pattern, the rest of my pattern really doesn't have to be indented. And really my pattern is safer. If someone else comes along and edits my pattern not understanding it fully, they're less likely to make a big mistake. Okay, next we will talk about for loops. We need for loops because we have lists. There is no array in TPL if you haven't noticed. What you would call array is something that we call list. One of the syntaxes of the for loop is to say for variable name in list do. And then you have your statements, and then you have your end for. There are some control statements also. There's the continue and break. One of these statements could be continue semicolon or break semicolon. Continue means stop executing the rest of the statements that go back to the beginning of go back to the top and go to the next variable in the list or the next item in the list. Break means completely stop executing the list, get out of the for loop. Over on the right, I have some examples. We have animal list is cat, dog, bird. And so here's a simple for loop. For pet in animal list, do log.info, I have a pet, and then the name of the pet enclosed in %signs. This pet is just a string in my log message, but this pet here enclosed in %signs is the variable pet, which points to first cat, then dog, then bird. And so the output of this for loop is I have a pet cat, I have a pet dog, I have a pet bird. The second example uses the continue and break statements. For pet in animal list do, if pet is equal to cat, the string cat, then continue, meaning go to the next item in the list, which is dog. So it would skip the rest of these statements. It wouldn't log anything. And then it would come back up to the top of the for loop and then use the next pet, which is dog. So then it would, then we have a dog now. So if pet equal cat, then continue. But pet is not cat anymore, it's dog. So now we come to the next if, which is if pet equal dog, then log at info level that I have a pet dog. So this will get logged, I have a pet dog. And then we will break completely out of the for loop and go on with the rest of the statements. So the only output of this entire for loop is I have a pet dog. Text statements, text dot something, these are used for string manipulation. These are just a few of the text statements available in TPL. I didn't list all of them. I find that text.join is especially useful. Say that we want to convert a list into a comma-separated string, we can use text.join as in the example on the right. So here on the right, we have the animal list, which is cat, dog, bird, and we check to make sure we have a valid animal list with the if statement. And then we say that animal string equal text.join of the animal list and a comma. So the comma means that we're going to use the comma. There's actually a space after this comma. So comma space will be put between each item in the list. So then we're going to log the value of the animal string, and the output will be animal string : and then single quotes, cat, dog, bird. Why are there single quotes? Because I put single quotes into the log string. I wanted to have a delimiter that delimits the beginning of my string and the end of my string. So that, for example, I know there's no leading spaces and there's no trailing spaces. So this is a useful trick also in your log statements. And we have a comma space between each item in the list because the delimiter was comma space here. that was the argument passed to text.join. Text.split here would do the opposite of text.join. It can take a comma-separated string like this one and split the items out into a list. In other words, it could create something like an animal list from a string. The separator, again, could be anything at all. It could be commas, spaces, colons, whatever you specify as the separator. There is no text.concatenate function, but concatenation can be accomplished using this syntax here. So, for example, we have stir1 and stir2, and then I'm going to create a new variable called concatenated string, :equal, and then in double quotes, I can put whatever I want and use the percent signs to get the values of stir1 and stir2. Then in this little fragment of code, I'm logging the value of the concatenated string, and the output will be combined ABC DEF, because that's what I put. I put combined as a string, space, the value of stir1, space, the value of stir2. So it's combined space ABC space DEF is the output in the log. Trigger statements are typically an assignment statement and a trigger statement combined. So the assignment statement creates a variable to point to the thing that was triggered on. In this example here, we have triggers on my process : equal. So this is the assignment statement part of it, and it's triggering on a discovered process node where the command matches a regular expression. This little hat Java, that means that the command starts with Java. When we find a discovered process in discovery that starts with where the command in the process starts with Java, then this pattern would trigger, and my process would point to that discovered process. Here's a different trigger on host : equal host, where name matches hat A. So where the host name starts with A, then this pattern will trigger. And here, the uppercase or the initial cap host is the host node that's being triggered on, and the all lowercase host is a name of a variable that's going to point to that host node. Discovery.run command is used to run a command on the remote host in the context of discovering that host. When we are discovering a remote host, we have the credential information, and therefore discovery.run command can execute a command on the remote host using the discovery credential. It is important to test that the result of discovery.run command has a value. And then if you want to check the result of the command, you need to use the .result, as seen here in blue. So here we are saying that the publisher command is Java-version. Actually, this isn't doing anything yet. It's just assigning a value, a string, to publisher command. Then we call discovery.run command. The arguments are the host node where you want to run the command, and then the command, which is here Java-version. So actually, we didn't even use this local variable. So that's kind of funny, but that's okay. We don't have to use it. Next, we're testing that ran command actually has a good value. If it didn't have a good value, it means that there was an error during the run command. So if there's an error, then you can't really use the result of the command. So if it had a good value, then we can set a local variable called result to the ran command .result, meaning the result of this run command. So ran command .result is the result of Java -version. Next, we're logging that information. We're saying that the publisher command output was %result, %. And then we're trying to get the publisher out of the result that was returned.
To get the contents of a file from a target host during discovery, use discovery.fileget. Similar to run command, this host is being discovered with a certain credential. So discovery.fileget is using the discovery credential to try to get the file. If that credential doesn't have permissions to see or get the file, then fileget will fail. Since it can fail, you need to test that the return value from discovery.fileget has a value. And if it does, then you can get the content to the file using .content. So here we call discovery.fileget with the host that we're going to retrieve the file from, and then the name of the file. And the result of fileget is going into the variable called info file. If we have an info file, then we can get the info file.content. So the and, when the first part of the and fails, then the second part of the and is not interpreted. It doesn't perform this action. So only if we have info file, then we can get the info file contents. So info file.content, we get the contents here and we're assigning it to be a variable called info file contents. There are many other discovery functions. I chose to cover these two because I find these two are commonly used. Now back to run pattern. If your pattern runs a discovery dot command, such as discovery.run command or discovery.fileget, remember that run pattern can't actually execute those commands on the remote server. There is no credential used in run pattern, and therefore there is no connection to any remote host. So how does discovery.run command work during run pattern? Well, if you have previously scanned the host, then these results are stored away from the previous run. So if those are good results, then your run pattern should behave well. But there is a chance that the previous scan didn't get good results, and so you can't always believe the results that run pattern is giving you. The bottom line is, if you are having trouble with run pattern, then just scan the host in a real discovery again, and then you can try to use the run pattern after the scan.
Okay, now there are model dot functions. There's many model dot functions, just as there's many discovery dot functions. I'm covering two of them. The first one is model dot node type. For example, model dot software instance. This command will create or update a software instance. The key is very important. If the key already exists on a software instance node, then that software instance node will be updated by this statement. If it's a new key, not existing yet, then the software instance will be created with that new key. The arguments to model.softwareinstance or model.any node type are, on the left, we have the names of the attributes that will be set. And on the right, these are the values of those attributes. So SI key was defined up here to be the type colon name of the SI. The name is just the name of the SI, the type, and the version. We also have model.addDisplay attribute, which is often used to add a new attribute to the display, to the UI display of that node. So here we're setting a new attribute on a host, host.alt_serial equal ABC123, model.addDisplay attribute, add it to this host node that's defined above somewhere, and the name of the attribute to be added is alt_serial. The older mechanism is something like this, host._tw metadata adders, and then it's a list of attributes that you want to add.
There's another model dot function I want to cover, which is called model.host with a lowercase h. And there's a equivalent function called related.host. Model.host is deprecated. It still works, but we're encouraged to use related.host instead. The reason model.host is deprecated is simply because model.host with a capital H is a very different function. So model.host with a capital H would create or modify a host node, whereas model.host and related.host, they take a node as an argument and they find the related host for that node. So in this case, process here points to a discovered process, and a discovered process should have an owning host. So calling model.host with process will return the host node that owns that process. So here's how we use it both ways, model.host or related.host. Next, I'm showing something that we're going to talk about, which is the search statement. So here we have the host, right, that we found was the related host for the process. And we're going to search in that host and traverse to the software instances of that host and return the software instances where the type is BMC Remedy AR system server. So search always returns a list, and in this case, it's returning a list of software instances on that host with the type of BMC Remedy AR system server. So here's some other examples of search. The first one is doing a search in a specific host and traversing to the software instances. But this time there's no where clause. So this search is returning all of the software instances on this host, and then this local variable will point to that list. Basically, in your patterns, sometimes you need to run a query to find some data. How do you run a query from a pattern? You use search. So here's two more examples. We have a local variable called all hosts, and it's equal to search of host. Instead of using the keyword in and then a node, this host with a capital H is a node kind. So this search is just searching for all of the host nodes in your discovery appliance and returning a list of all of them as all hosts. And likewise, this search is also searching through all the hosts, but returning only the ones where the OS class is Windows. And then this variable called Windows hosts will point to the list of all the host nodes of type Windows. And now I will show another demo. Let's say that I would like to know if I have any remedy software running in my environment. I can just go to the global search and look for remedy. The global search returned 16 software instances, and it returned some other things like some of the files that were discovered contained the word remedy. There's some packages and processes that contain the word remedy. Lots of things it found. One thing interesting it finds is some patterns that contain the word remedy. And patterns are contained inside of pattern modules. Now, if I didn't have any remedy patterns, I wouldn't have discovered any remedy software. To make that clear, software is discovered by patterns. I am interested in looking at the software. So I'm going to choose one of the software instances here. First, there's the visualization, and then there's all the details in text. So there's the name of the software instance and the type, BMC Remedy AR System Server. Now, this is the maintaining pattern. When I bubble over it, it shows if I were writing a query and I said search software instances, how could I find all the maintaining patterns? I would use the traversal element :maintainer :pattern. Now, also running on a Remedy AR server, you might expect to have an Atrium CMDB. So I would like to see if we have any CMDB. And yes, we have. I'm interested in the software, so I'm going to go to the software instance. We have 4 of them. And if I look at one of them, then there's the visualization. this is the Remedy AR server, and this is the CMDB that is related to it. Actually, this is related through observed communication. And then this is a different AR server, which is related to it through a dependency. So actually, this is the AR server where this CMDB resides. This other AR server is just something that it was seen to be communicating with. So these are the details of the CMDB software instance, the host that it runs on. Okay, now these are interesting. This is the outgoing communications that were observed to this Remedy AR server. And this one, that depends on software instance. So this CMDB software depends on this Remedy software instance, Remedy server. The CMDB doesn't exist without the Remedy server. So the CMDB software depends on the Remedy server software. Now, how did this get created, this dependency relationship? Well, to find out, I want to look at the pattern that created the CMDB software instance and the pattern that's maintaining it. And that's this pattern right here. It says maintaining pattern. This is the actual pattern itself written in TPL. The first thing that my eye goes to is the trigger. Now, this is the pattern that creates the Atrium CMDB software instance. The trigger is on a discovered process where we have a command, a discovered process called ARCMDBD. And we haven't shown this syntax yet, but the command matches a Unix command style or a Windows command style. The reason we have Unix style versus Windows style is because in Windows, this would have a .exe on the end, but in Unix, it would not. Now, you saw this earlier. We're saying host is the model.host of the process. So the process points to the discovered process that triggered this pattern. And now we want to know what host is this running on. So we say this host is model.host. Remember, model.host is deprecated, and now we would use related.host. But many of the out-of-the-box patterns were written before model.host was deprecated. Okay, then we have some logic. If the host is Windows, we do certain things. And to find the end of this if, hopefully this is well indented, and it is. So there's else, meaning if it's Windows, then do this stuff. Else, if it's not Windows, i.e. it's Unix probably, then do this stuff. Okay, finally, we have an if there was an install root, meaning if we found the installation of this software, then we can use that knowledge to create the software instance. Otherwise, we're going to create the software instance here. So there's two different branches where the software instance could be created or modified. What I see here is that if we had an install root, then the key uses the install root followed by the type, followed by the host key. But if we didn't have the installation directory, then the key is just the type and the host key. That seems to be the main difference, although up here we also have an additional attribute called install root. And down here, we don't have that attribute. After we have created the software instance in this pattern, then it says we're going to look for relationships to an AR server. And it does that by looking at the arguments of the discovered process. So we're setting something called AR install root. And if we didn't find it, if not AR install root, and we did find the server name and the host is a Windows host, then we're going to run a query on the registry. We didn't talk about this, discovery.registry key. We're going to look in the registry key to see if we can find the AR server on this registry key. And if we found it, then we can set the AR install root variable to be the proper value that we found in the registry. Finally, if we have an AR install root, then we set the AR install root attribute on the software instance node, the one that was created right here. SI node points to the software instance that we created or modified. So here we're setting an attribute called AR install root on the software instance node. If we found the install root, then like I said, we're adding this new attribute, but we're also doing a search. So we're searching in the host all the software instances running on the host that's hosting this CMDB software and looking for an AR system server software instance on that host that has where that software instance has the same install root or a portion of it. So if those are the same, then it comes back as the list of AR SIs. If we didn't have an install root and we only had a server name, then we do a slightly different search. So we're searching in host and traversing to the software instances of that host, where the type is Remedy AR system server, and the server name matches. So the server name of the CMDB software matches the server name of the Remedy AR system server software. If those match, then it's returning this list of AR SIs. Now, what are we doing with the AR SIs? Well, if we have AR SIs, then we're creating a dependency relationship, model.rel.dependency. Remember I said that there were a lot of model.commands. commands. So yes, model.commands can create relationships between things, between nodes. In this case, it's creating a dependency relationship between the SI node, which is the CMDB software, and the AR SIs. There could be one or more of these. And there's a log statement telling you that a dependency relationship was created. So originally I asked, how did we create the dependency relationship? Here it is right here. So let's take a look again at that dependency relationship. And here it's written as depends on software instance. And it shows that this, we're looking, if we scroll up, we see, what are we really looking at? Sorry, we're looking at the Atrium CMDB software instance, and it has a dependency relationship with this AR server. Now, if I click on the dependency here, the AR system server, then of course I'm looking at the software instance, the BMC Remedy AR system server. And we can see here that it is depended upon by these software instances. There could be a list here, but there happens to be one. So AR system server is depended upon by the CMDB software. So you see the dependency relationship in from both directions. So once again, I'm looking at this bubbling. It says depended upon, dependency, dependent, software instance. I would like to find, again, my list of Remedy software instances. Here they are. And click on Customize and go down to the relationships. Oh, here they are. I'm going to click Show All. And I'm going to look alphabetically. I'm going to look for Depend. There's not any depend. So oddly enough, this is a case where we have a relationship, but the relationship is not showing in the customize place. Not every feature is available in customize. Let's look at the raw query. Okay, let's do the trick from the first webinar. I'm just adding something again and then looking at the raw query. Okay, the reason I did that is I just want to look at a traversal here. Okay, I'm going to take this query and I'm going to modify it. So I'm going to go to Explore Query, paste in that query. I'm going to remove the one attribute I had added on the end. I took that stuff from the bubble and I pasted it there. And now I need to say what attribute I want from there. And so I'm going to say .name as depended upon. Now you see that this is a list of AR system server software instances, and 2 of them in the list, let's just sort by dependent upon. 2 in the list have a relationship to an Atrium CMDB. And now I will talk about some best practices. First, you should always be aware of where in your pattern your variables are set, where they have values. So the first example on the left looks okay to many people, but notice if XYZ then set the location to Austin, and if. Then outside of the if, we're trying to use the value of location. But what if XYZ didn't have a value? Then location doesn't have a value. So this is bad code. If you uploaded the bad pattern, then you would get a warning that location may not have a value. And that's why you get that warning. In my opinion, it is a good idea to define all the variables you need to use at the top of your body and assign a value of none. That way you can avoid a trap. So on the right, here at the top of the body or toward the top of the body, we're setting location to none. And that's the only line that we changed. So location is either none or it's Austin. And then it's okay for us to assign host.location to be location that has a value of none or Austin. We talked about the stop statement. You should use the stop statement early and often. Check for any bad conditions under which you don't want to run this pattern. If you have that condition, then stop. And then you don't need to have a lot of nested if statements. You just say, if this condition, then stop. You don't need to say, if this condition, then stop, else do this. That doesn't make sense. That's just an unnecessary indentation. Okay, like I said on the last slide, I think it's a good idea to initialize your variable at the top of the body and just set them all to none, for example. You should test that a variable has a value before trying to use it. So we've seen this a lot in this talk. If host, then model equal host.model. We don't want to say host.model if host has no value. That will cause an error, a runtime error. We should add logging to our patterns that we write to help debug the patterns. Of course, that's very important. That's a best practice. And using run pattern is a very useful tool and a best practice to test your pattern. If your pattern has discovery.commands in it, then you're going to want to run a scan with the pattern active first. And then after you have run a scan of maybe 1 host or 2 hosts, then you can use run pattern after you've run the scan. Keep in mind that everything in the TPL is case sensitive. And when you're creating your own variable names, in my opinion, they should be lowercase. Why? Because you want to distinguish your variable names from things that Discovery has as constants, such as node types like host or software instance, and those things start with an initial cap. Some common practices can be confusing. In this fragment, location is used as a variable with a value, and it is also used as the name of an attribute on the host node. The orange location is the name of a variable with the value Austin. But the blue location is the name of an attribute that we are adding to the host node, and the value is being set to Austin, i.e. the value of the location variable. This is commonly done in the out-of-the-box patterns, and some people find it confusing. Where can you get help with custom patterns? In the UI, there are some sample pattern templates. If you go to Manage Knowledge, Create Patterns. Or in the Discovery community, you can ask questions about patterns and you can find many samples. There's also some Helix support Discovery blogs, which sometimes give information about patterns or show samples. Again, you can ask questions in the community. You could open a support case. Depending on what kind of help you need with your customization, we might or might not be able to help you. If you have a large project, you can contact BMC Professional Services. If you open a support case for a very large statement of work, we will tell you to contact the professional services. If you're seeking help with custom patterns in a support case or on the communities, then it's very important to clearly specify what you want to do. Do you want to add some new data to the Discovery data store? Where do you want this new data? What node type do you want the data to be on? A host node, software instance node? What attribute do you want to add or modify? Do you want to change something that's already existing, or did you want to add something new? It's better to add new things. We don't recommend that you change existing attributes. Or did you want to add some new data to the CMDB? Where in the CMDB? What class? What attribute? I haven't talked about the CMDB sync mappings, but everything that is performed in the CMDB sync is dictated by some CMDB sync mappings. Here's some reference links. There's the pattern language in the documentation. There's the Configipedia Documentation and the Discovery community. Configipedia tells what software and network devices are supported out of the box by Discovery. So in summary, I've shown you how to use run pattern to test a pattern that you're developing. I've discussed the basic constructs of the pattern language, such as if statements, for loops, the data types, etc. We've reviewed some best practices, and I told you where you can get help with custom patterns. And that concludes my presentation. Back to you, Greg.
Thank you. And now I'll take us through the self-help in contacting BMC. The YouTube channel where this webinar will be posted is listed here. It contains past webinars as well as a rich set of how-to videos. The Connect with BMC Helix ITSM and Remedy webinar schedule is available at this community's link, and the hot off the press newsletter for trending information is available at this community's post. As always, contacting technical support via web, phone, email, and these social channels is available. At this time, that will conclude this webinar. Thank you for attending.